find, now this notation, just to remind you, when you see this small n with parentheses around a name of a set, that means the number of elements in the set. In fact, if you want a formal definition, the number of elements in a set A is called the cardinal number of the set A, and this notation, small n with the set name in parentheses, is what we use to say that. So technically it's the cardinal number of the set, but we usually just say loosely the number of elements in the set. Now, once you know that part, you still have to figure out how to answer the question. And what I notice about these numbers is they're consecutive. 103, add 1, you get 104, add 1, you get 105, add 1, you get 106. So that's the pattern all the way to get to 123. Now, if you want to count the number of elements in the set, I suppose one thing you could do is just eliminate the ellipses and write them all out and then just count them one by one. That would probably work here. Not very efficient, but would work. But if the number were 103 to 1023, that would be just impractical. So what I want to remind you of, there's a shortcut way to do this if the numbers are in the set are consecutive, and that means they differ by 1. So even though all we're trying to do is count them, they're not all written down and they're consecutive. So the trick is, all you need to do is find the largest one and the smallest one, subtract and add 1. Now, I always get the question, well, why do you have to add 1? And I would say take a really, really simple example and see why you would have to add 1. So forget about A just temporarily, and suppose the set were different. Suppose you had a set U consisting of 4, 5, and 6. If you just took the largest minus the smallest, you'd get 6 minus 4, which is 2, and that's not right. There are clearly 3 elements. You have to add the 1 to get the number of elements. So going back to the problem we're actually working, 123 is the largest, 103 is the smallest. If you put those in, subtract and add 1, 123 minus 103 is 20, 20 plus 1 is 21. So the number of elements, or the cardinal number of that set, if you want to be formal, is 21. Let's do another. Find the number of elements in set A for the following set. This time the set is written in set builder notation. It's the set A, which consists of the set of all x's such that x is a woman who served as U.S. Vice President before 1900. Now, I hope you wouldn't have to do what someone obviously did. I actually saw online where someone asked a question about this on Google Answers. And I hope you don't have to do that to know this answer, but I thought just for the fun of it, it would be sort of interesting to see what this exchange looked like. There was someone who went online into Google Answers and asked this question: who was the first female vice president in the USA? Several people responded, but the one that was chosen as the best answer was someone named Matt, and Matt's response started off like this: there has never been a female vice president of the USA. He went on to say more, and although we don't need more to answer this question, I thought it was sort of interesting. Do you remember who that nominee was that was not a vice president, but that actually ran for vice president on the ticket? Do you remember her name? Well, he went on to say, there has, however, been a Democratic nominee. Her name was Geraldine Ferrara. And again, he went on further, but I thought I'd pause. Do you remember who she ran on the ticket with? Well, as he continued on, whose Dukakis ticket, she ran with Michael Dukakis. Do you remember what happened? This was in 1984, and that ticket lost the election by a wide margin. Do you remember who to? To Ronald Reagan and George H.W. Bush. So really the only thing you needed to answer this question is this first thing, that there's never been one. But I thought the rest was sort of interesting, so I threw it in. Hope you didn't need to Google it or put it into Yahoo Answers to get it, but the bottom line is there has never been a female vice president of the USA, so the number of elements in that set is simply 0.